Operation Cedar Cut, 1874, was supposed to be a routine municipal inspection, a simple sewer reinforcement along Broadway near Murray Street. As part of New York City's ongoing efforts to maintain aging infrastructure, workers and engineers expected nothing more than liquefied earth, clogged conduits, and standard masonry repairs. But what they uncovered beneath the bustling streets did not match any recorded history, any known engineering standard, or anything expected to exist beneath an 1870s city. Beneath layers of compressed soil and stone, a network of cylindrical tunnels stretched farther than any contemporary map indicated. The walls were not simply brick or cast iron. They were lined with a metallurgical composition that defied period capabilities. Valves, pressure chambers, and conduits were precisely machined to tolerances smaller than a 1/16 of an inch, as if designed for a system centuries ahead of its time. Tools faltered, sketches faltered, and the routine inspection dissolved into a series of unanswered questions about what Manhattan had concealed below its streets for decades, or perhaps centuries. Official municipal records claimed that beneath Broadway lay only standard sewer lines, water mains, and telegraph conduits, constructed with the known materials and techniques of the 1870s. Maps, from 1869 to 1873, held in the city archives, confirmed these installations, showing no tunnels wider than 2 feet, no pressure chambers, no subterranean transportation mechanisms. Yet the structures discovered by the workers exceeded these specifications in scale and sophistication. Entire segments of tunnel ran perfectly straight for hundreds of feet, aligned precisely with Manhattan's street grid, and in some cases, fused directly into bedrock. The first sketches sent to city engineers were met with confusion and dismissal. Official correspondence noted the tunnels only as unclassified utility conduits, a phrase that would later appear repeatedly in reclassified and suppressed documentation. The anomaly's existence challenged the very assumptions of 19th-century urban engineering, yet it quietly vanished from public attention. The first contrast between the officially sanctioned infrastructure and what lay beneath the surface was stark, immediate, and impossible to reconcile with any known timeline. To understand the scale of this contradiction, one must first consider what should have been underground. According to period engineering standards, water mains and sewer lines of the era were typically constructed from cast iron or brick, extending no deeper than 20 feet below street level to accommodate the relatively shallow bedrock of lower Manhattan. Telegraph conduits and gas lines were interspersed, rarely exceeding a diameter of 12 inches, with junctions and chambers constructed with minimal precision. Municipal engineers of the 1870s operated within well-documented tolerances, often dictated by the limits of hand tools and steam-powered equipment. Excavation logs of the time describe standard soil removal, occasional bedrock cutting, and the reliance on lime mortar for masonry adherence. Yet the tunnels uncovered during Operation Cedar Cut were measured at nearly 5 feet in diameter, featuring smooth walls of a material resembling cast bronze fused with an unknown alloy. Pressure-regulated valves were embedded along the network at intervals of exactly 30 feet, with wear patterns suggesting long-term use. These specifications far exceeded what any engineer of the 1870s could construct. Yet the structures were real, physically present, and in perfect alignment with the city's surface grid. Yet this never appeared in official records. The first anomaly revealed itself most clearly in a section beneath City Hall Park. Excavators had anticipated soft earth and standard municipal conduits, but instead discovered a horizontal shaft extending 42 feet below street level, carved directly into bedrock and lined with metallurgically advanced materials. The tunnel's circular cross-section was perfectly uniform, its joints sealed with a precision compound that preserved internal pressure. Pressure valves, fitted into the walls at exact intervals, appeared to regulate a system capable of moving significant mechanical load, suggesting pneumatic propulsion. Further along, chambers resembling capsule bays were embedded into the sides, their interiors precisely machined and showing wear patterns inconsistent with a brief experimental installation. Sketches of these chambers were forwarded to city engineers, but within months, the documents were minimized, some mislabeled as standard utility work, and others quietly removed from circulation. The physical evidence alone demonstrated that what lay beneath Manhattan was not only forgotten, but intentionally obscured, hidden behind the veneer of ordinary infrastructure. Workers who descended into the shafts reported an uncanny silence, a uniformity, and an engineering perfection that could not be replicated with contemporary tools. The implications of the discovery demanded attention, yet official response was minimal. Surviving excavation notes, partially redacted municipal reports, and archived sketches suggest attempts to obscure both the scale and purpose of the tunnels. References to pressure systems were replaced with vague statements about utility conduits, while detailed diagrams of junctions and chambers were removed from circulation or stored in misfiled records. Photographs of the shafts, taken on 4x5 daguerreotype plates, were preserved only in scattered private collections, never to be published in city engineering logs. The fragments that remain indicate not only that the tunnels existed, but also that their origin predates the city's documented development schedule. As the first chapter of this investigation closes, one must confront the unsettling question: who engineered these subterranean systems, and for what purpose? What evidence lies suppressed within the archives, mislabeled, or quietly erased, waiting to reveal a truth about New York's foundations that the public was never intended to follow? Beneath Lower Manhattan, the first full segment of the Pneumatic Transit Tunnel revealed its anomalous nature immediately. The cylindrical passage extended nearly 300 feet beneath Fulton Street, 45 feet below the surface, aligned perfectly with the street grid above. Its walls, a bronze-like alloy unknown to 19th-century metallurgists, were polished to a uniform sheen, smooth enough to reflect the faint lantern light of the workers who documented its existence. Supporting ribs were spaced at exact 12-foot intervals, seemingly designed to withstand pressure far greater than any municipal sewer could require. Excavation sketches from 1874 show the tunnel bisecting pre-existing masonry, yet without disturbing it, indicating a construction sequence and engineering capability inconsistent with recorded city development. Layers of liquefied earth had settled against the walls in patterns suggesting centuries of compression, yet the structure showed minimal signs of stress or corrosion. Surviving daguerreotypes preserved in private collections capture the tunnel's curvature and seamless joints, elements that, for decades, were absent from any public municipal record. A few blocks north, a pressure valve housing discovered beneath Maiden Lane defied both logic and known technology of the era. Measuring nearly 3 feet in diameter and 1 foot thick, the valve featured a rotational mechanism with tolerances smaller than 1/16 of an inch. Metallurgical analysis, reconstructed from surviving excavation notes, indicated an alloy composition not synthesized in laboratories until the mid-20th century. The housing was fused into surrounding bedrock, aligned perfectly with the larger tunnel network, and contained engraved indicators suggesting a complex system of pneumatic regulation. Municipal engineers of the 1870s could not have designed a valve capable of sustaining the pressures implied by its construction, yet there it sat, documented in sketches, photographed in detail, and quietly excised from official logs. The housing appeared both functional and standardized, implying that it was part of a broader, operational transit system rather than a singular experiment. Further evidence emerged in the form of capsule bays embedded along the tunnel under Vesey Street. Each bay measured 10 by 15 feet, carved into the bedrock and lined with the same advanced alloy as the tunnel walls. Where patterns inside the chambers indicated repeated use, floors were slightly grooved in precise intervals, suggesting the movement of wheeled capsules or carriers. Engineering schematics, partially recovered from misfiled archives, depict identical bays spaced at regular intervals of 50 feet, demonstrating a level of standardization inconsistent with any known construction project of the 1870s. The capsules themselves were absent, but the chambers retained pressure seals and access hatches with precision latches, each engraved with serial numbers or symbols that remain These bays, perfectly preserved, convey the impression of a long operating system, one that existed well before any public record claimed such technology was feasible. Ventilation shafts offered further testimony to the network's sophistication. Beneath the corner of Broadway and Liberty Street, shafts rose from the main tunnels and were fused seamlessly into masonry predate 1850. The alignment suggested they had been incorporated into the urban grid long before official documentation accounted for their existence. Each shaft was equipped with pressure relief valves and directional flues, etched with measurement marks that corresponded to diameters of exact multiples of 5 inches. Geological surveys included in surviving excavation logs revealed that liquefied earth had partially filled some of these shafts over time, yet the shafts remained structurally sound, indicating engineering beyond contemporary understanding. Photographs show the shafts intersecting with foundations of buildings thought to have been constructed decades later, creating a temporal contradiction that remains unresolved in municipal records. Perhaps the most compelling anomaly lay in a control interface discovered along a tunnel segment beneath Wall Street. A rectangular panel 2 feet by 3 feet, embedded into the tunnel wall, contained a series of levers, pressure gauges, and valve access points. Precision tolerances on the levers suggested repetitive, calibrated operation, while the pressure gauges were calibrated in units not standard to the 19th century. Sketches and diagrams, suppressed or indicate the panel controlled airflow across multiple segments of the tunnel simultaneously, implying a coordinated system designed to move capsules or mechanical components with speed and reliability. Surviving daguerreotypes capture the interface from several angles, revealing inscriptions that predate any known standardized engineering lexicon. The combination of material, precision, and function suggests an intentional design of extraordinary sophistication, inconsistent with all known historical infrastructure in the city at the time. Each discovery built upon the previous, creating a stacked effect of anomalies that became increasingly impossible to reconcile with the official narrative. Early photographs, engineering, schematics, excavation notes, and geological surveys collectively depict a subterranean network engineered with precision, foresight, and technological capabilities far exceeding contemporary understanding. The tunnels, valves, capsule bays, ventilation shafts, and control interfaces together form a coherent system, suggesting that the pneumatic transit infrastructure was operational, standardized, and deliberately concealed. Yet almost none of these details appeared in public records, municipal reports, or engineering logs. Every artifact, every diagram, every photograph survived only in scattered fragments, misfiled or minimized, leaving modern researchers to reconstruct the evidence from whispers in archives. Visualizing the tunnels in 3 dimensions, one sees a hidden world beneath Manhattan, a network aligned with streets, fused into bedrock, polished to precision, and engineered with a knowledge the city's official records never admitted. Each segment reinforces the undeniable conclusion that something far older and more advanced than the 1870s existed beneath the streets, quietly erased from the historical record. Beneath the streets of Lower Manhattan, the pneumatic transit system, revealed in the previous chapter, was only the surface of a far more complex engineering feat. The core system, spanning multiple blocks beneath Fulton, Vesey, and Wall Streets, operated on a principle of air pressure propulsion that exceeded any officially documented technology of the 1880s. Cylindrical tunnels, 5 feet in diameter, were lined with a bronze-like alloy capable of withstanding pressures exceeding 50 pounds per square inch, a measure entirely absent from municipal engineering literature of the era. Each tunnel segment was equipped with embedded valves, precisely machined with tolerances no larger than 1/16 of an inch, connected to a network of distribution ducts that ran parallel beneath the main line. Pneumatic capsules, now long removed or vanished, appear to have traveled along these tunnels with a speed and efficiency that would rival systems only documented in the 20th century. Surviving sketches depict a pressure regulation system controlling airflow across multiple segments simultaneously, suggesting an operational understanding of fluid dynamics far advanced for the period. The propulsion method was particularly remarkable. Capsules were likely moved by modulating air pressure within the sealed tunnels, using a series of valve chambers placed at 30 to 50-foot intervals. Some chambers included relief vents and control panels with engraved serial numbers, indicating precise calibration for each segment. The alignment of tunnels, pressure chambers, and valves corresponded exactly with the city's street grid, requiring exact surveying techniques and mechanical execution beyond the capabilities of contemporary surveyors. Excavation sketches from 1874 show cross-sectional diagrams with labeled airflow directions, valve types, and calculated tolerances, yet the documentation was quietly removed from circulation, relegated to misfiled engineering logs. The system's design implies not a temporary experiment, but a fully operational pneumatic network, maintained with standards that predate similar documented technology by decades, if not centuries. The sophistication of airflow regulation, coupled with the uniformity of tunnel construction, indicates a highly advanced knowledge of mechanics and urban engineering that cannot be reconciled with the officially recorded capabilities of 1870s New York. A detailed technical breakdown of the system reveals further anomalies. Materials used in the tunnel linings, valves, and capsule bays contain alloys not documented until the mid-20th century, resistant to corrosion and capable of maintaining structural integrity under long-term pressurization. Valves were precision machined with interlocking seals, employing pressure-tolerant compounds that modern metallurgists only reproduced using techniques unavailable in the 19th century. Capsules, inferred from wear patterns in bays, appear to have been standardized to fractions of an inch in diameter, with floors and rails engineered to exact specifications. Load tolerances were calculated to distribute weight evenly across multiple segments of the system, preventing collapse or deformation despite repeated, heavy usage. Relief vents, control levers, and airlocks were positioned according to mathematical ratios, suggesting an applied understanding of pneumatics and fluid dynamics far in advance of what municipal engineers could achieve. Even the smallest components, hinges, latches, and pressure gauges were uniform across the entire network, indicating industrial-scale standardization that predates documented mass production practices in America. When compared to the officially recognized technological timeline, the system becomes increasingly impossible. In 1874, pneumatic systems in the United States were largely exploitable, limited to small capsules or mail transport in single buildings. No city-level underground transit relied on precise air pressure for propulsion, nor did any engineering manuals describe high-pressure bronze, alloy tunnels, or valve networks capable of sustained operation. According to municipal engineering records, tunnels beyond 20 feet were primarily sewer conduits, with masonry designed for minimal mechanical stress. Yet the evidence uncovered in Manhattan shows tunnels extending 45 feet below street level, perfectly aligned, pressure-sealed, and capable of moving mechanical capsules over hundreds of feet. Components that should not exist in the 1870s were widespread, standardized, and operational. Surviving archival evidence confirms that municipal engineers of the period were aware of the structures, yet official records contain only vague references, mislabeling them as utility conduits or omitting mention entirely. This chronological discrepancy highlights a technological sophistication that does not belong to the 19th century. Engineering impossibility becomes most apparent when examining wear patterns and construction precision. Capsule bays exhibit grooves and indentations consistent with repetitive movement, aligned with exact spacing tolerances measured in fractions of an inch. Valves show signs of long-term operation, yet no corrosion or failure expected from exposure to pressurized airflow and environmental factors is present. Control panels demonstrate uniform levers and calibrated pressure gauges, engraved with numerals and symbols consistent across multiple tunnel segments. The precision of the system, the repeatable measurements, and the standardized components defy contemporary knowledge of construction methods. No modern expert can explain the manufacturing techniques, the materials, or the applied fluid mechanics evident in the surviving fragments. The tunnels, capsules, and control systems together illustrate a fully functional, technologically advanced network whose sophistication is both undeniable and inexplicable within the context of recorded history. Yet almost none of this appeared in official records, and the documentation that survived was quietly minimized, mislabeled, or removed from circulation. The evidence presents a clear pattern, a network built with knowledge and precision far beyond the era it supposedly predates, a system operational, standardized, and entirely hidden from public view. This chapter establishes the impossibility of the Manhattan pneumatic system according to the historical timeline. From bronze-lined tunnels and pressure-regulated chambers to capsule bays with repeated wear and uniform control panels, the engineering is precise, standardized, and wholly incompatible with 19th century capabilities. The surviving documentation, daguerreotypes, excavation sketches, and partially redacted municipal reports confirm that these anomalies were known, recorded, and subsequently suppressed. Each detail, from material composition to mechanical tolerances, reinforces a simple but profound truth. The city beneath New York harbored a technological infrastructure far beyond anything the official history acknowledges. As we proceed, the focus will shift from physical discovery to the deliberate suppression of evidence. The language shifts in official records, and the questions that remain unanswered, leaving us to confront the possibility of knowledge intentionally erased from history. Evidence of deliberate suppression emerges almost immediately when examining the Manhattan Pneumatic network. Municipal records, once containing detailed sketches, excavation logs, and measurements, vanished or were quietly reclassified within months of their initial creation. What had been meticulously documented in 1874 as subterranean tunnels and pneumatic chambers became, in later reports, utility conduits of undetermined function, or was omitted entirely. Sketches showing valve placements, capsule bays, and pressure chambers were removed from public files, stored in misfiled ledgers, or erased from circulation. Excavation logs recorded in the city engineer's office note the precise diameter, depth, and material composition of tunnels. Yet surviving summaries condensed these into single-sentence entries, stripping context, eliminating diagrams, and eliminating dates that might have revealed their true construction sequence. Even reports of liquefied earth conditions and the alignment with pre-existing masonry were minimized, implying only standard sewer maintenance rather than a complex mechanical system. The systematic reduction of detail across official records suggests more than administrative oversight, indicates intentional concealment. Physical interventions further reinforce the impression of suppression. Sections of tunnel were quickly sealed with concrete, filled with rubble, or labeled structurally unstable, despite surviving evidence indicating no immediate danger. Ventilation shafts, originally documented and photographed, were capped and obscured within months of excavation, while capsule bays were buried under street-level fill without explanation. Photographs from early inspections, captured on daguerreotype plates and showing the true scale of the tunnels, were later referenced only in private engineering notes, never included in municipal publications. Even when images survived, captions shifted in language over time. What had once been identified explicitly as a pneumatic chamber, pressure-sealed and operational, was later described as a small, enclosed maintenance shaft or utility anomaly. Terminology drifted deliberately, softening technical certainty into ambiguity, ensuring that anyone consulting later records would perceive the tunnels as inconsequential or non-existent. Layers of archival redaction and selective filing paint a picture of an infrastructure quietly erased from public consciousness, a hidden system removed from both observation and scrutiny. The pattern of suppression invites a series of pointed questions. Why do tunnels exist at depths and with construction methods entirely inconsistent with 19th century municipal capabilities? Why were valve chambers, capsule bays, and pressure-regulated shafts quickly labeled unstable and buried, rather than studied or preserved? Why do early excavation photographs show alignment and structural precision that later municipal reports claim never existed? Why did engineering documentation shift abruptly from detailed logs to ambiguous one-sentence summaries, minimizing every technical measurement? And why does the timeline of construction and operation contradict itself repeatedly, implying either a far earlier installation or an entirely unknown technological source? These questions cannot be ignored, for they reveal gaps in the historical record that extend beyond mere administrative error. The anomalies persist, yet the city's official narrative has erased, obscured, or minimized their significance. Transitioning from suppression to broader implications, it becomes clear that the concealment of this system was not accidental. Archival records, redacted sketches, and photographic evidence all indicate a pattern of active removal and deliberate obfuscation. Each misfiled ledger, each erased diagram, and each ambiguous report reflects an effort to prevent public awareness of technological capabilities that existed far ahead of recorded history. The alignment, precision, and scale of the tunnels, combined with the systematic reclassification of supporting documentation, point to a sophisticated understanding of mechanics and urban planning, deliberately hidden from historians, engineers, and citizens alike. The evidence forces a re-evaluation of what is assumed about New York's infrastructure in the 19th century, suggesting a subterranean world operating beneath the streets, unseen and undocumented, whose existence challenges the completeness of official historical narratives. As we move to the final chapter, the focus shifts from the evidence itself to its implications, revealing how these discoveries fundamentally rewrite what we know about the city's technological past. leaving open the possibility that far more remains buried literally and metaphorically beneath Manhattan. The evidence uncovered in Manhattan's subterranean tunnels challenges the very foundation of recorded history. The pneumatic transit network, with its bronze-lined tunnels, pressure-regulated chambers, capsule bays, and precision-engineered control interfaces, demonstrates technological capabilities far beyond the 1870s. Standard engineering manuals, municipal records, and contemporary construction practices cannot account for the scale, sophistication, or operational functionality observed beneath the city streets, where patterns indicate repeated use over decades, while the uniformity of components suggests a standardized mass-produced system, entirely incongruent with known industrial methods of the era. The alignment of tunnels with the street grid, the integration into bedrock, and the meticulous calibration of valves and capsules all point to an infrastructure that predates recorded timelines, revealing a hidden layer of urban engineering that has remained intentionally obscured. Each discovery, from tunnels to control panels, reframes our understanding of New York's development and raises profound questions about the technological knowledge present in a period thought to be far simpler. Equally significant is the evidence of deliberate suppression. Municipal records containing detailed sketches, excavation logs, and photographs were quietly reclassified, misfiled, or removed from circulation. Language in official reports shifted from precise engineering terminology to vague, dismissive phrases, transforming complex systems into utility conduits or structurally unstable shafts. Surviving documentation confirms that key details, materials, tolerances, and operational schematics were minimized or omitted entirely. Photographic evidence, once clear in depicting tunnels, chambers, and control interfaces, was relegated to private collections, never integrated into public archives. The removal and redaction of these records was systematic, ensuring that the full scope of the pneumatic transit system could not be easily reconstructed or understood. Passive documentation and selective archiving indicate an intentional effort to obscure knowledge that existed beneath the city, leaving only fragments for researchers to piece together. This investigation ultimately descends into a hidden subterranean world beneath Manhattan, revealing a network whose purpose, origin, and operational timeline remain unresolved. The tunnels stretch beyond documented construction boundaries, while pressure-regulated chambers and capsule bays suggest a functional transportation system far ahead of its era. Control interfaces with engraved serial markings hint at operational sophistication that defies explanation. Each anomaly is corroborated by surviving sketches, daguerreotype photographs, and archival notes, fragments that survived deliberate suppression. Yet, despite the meticulous evidence, no definitive conclusion can be drawn. The system's builders, timeline, and intended use remain unknown. What is undeniable, however, is that the city's official narrative omits a hidden layer of history, deliberately erased from records, minimized in reports, and concealed beneath the streets for reasons that may never be revealed. The tunnels, valves, and chambers suggest that Manhattan, and perhaps other cities, were constructed atop infrastructure whose technological capabilities exceed those attributed to the period, hinting at a world deliberately hidden from view. This is the investigation they hoped the public would never revisit, a descent into the buried foundations beneath New York, and the discovery that suggests the city was built atop a network with capabilities far beyond anything recorded in mainstream history.